This talk will be maybe a little bit high level, meaning the stacks of tooling we have, because I'll be talking about debuggers. Question number one, who cares about debuggers? Oh, looks like many people do. That's wonderful. Well, this doesn't necessarily make my talk relevant for you, because who implements debuggers? Oh, quite a few people in the room, actually. Yeah, so this is more relevant for people implementing debuggers for their JVM languages. OK, so this is my replacement for a traditional legal slide here. So what I'm telling is not necessarily a lie, but it's a report and work in progress. So most of it already works. The rest will work probably in a week from now or something. OK, so what about debuggers? Actually, the thing with debuggers is that people take them for granted. It's like, if you roll out a really awesome debugger, nobody notices that, because it's kind of should be there anyways. But if you don't, people kind of scorn at you, because it should be there. So what a debugger can do? Normally, since like early 90s, we can stop at breakpoints, we can inspect memory, inspect call stacks, see what's in the local variables, what's in the fields of our objects, so on and so forth. This is very basic functionality. Everybody has that. And actually, this is something you get out of the box if you compile to JVM bytecodes, because any generic debugger in any IDE will just step through any Java code, any bytecode, and probably map it back to your source files. So this is more or less automatic. You don't have to do much to make that work. Now, there are more advanced features. Like, you can evaluate an arbitrary expression in a modern debugger. Like here, I just took this constructor call from the middle of my program and asked the debugger to evaluate it for me. It shows me a new object, its contents, so on and so forth. The same thing happens when you, say, set a watch. If you want to watch the value of some expression, or you can actually just ask it to evaluate some code for you. Like here, it's not even an expression. It's a sequence of statements. And this is what people do to see what's happening in their programs. Also, the same thing happens when you set a conditional breakpoint. For example, I only care about big collections here. A big collection is something bigger than 2 elements. So when I stop at a breakpoint, I don't want to be bothered if the collection is too small. I want the debugger to notify me only if it's big enough. So all these things require the same functionality. You take an arbitrary expression written in your language, you want to evaluate it. OK, sounds good. Now, how we do that? Our working horse is definitely JDI, the Java Debugger Interface, which is wonderful, but not all-powerful. For example, it doesn't know Kotlin or Scala or even Java, actually. So what it can do with the bare JDI is read variables, or write variables, actually, read or write fields, call methods. Actually, I can do many more interesting things, like finding all references to a given object, stuff like that. But this is not something we're going to use for evaluate expression. So you don't get evaluate expression out of the box. You have to implement it specifically for your language. By the way, if anybody has questions, go ahead and ask them right away, because I don't have very many slides today, so I'm on the short side. I have time to take questions on the go. Any questions at the moment? OK, should be pretty straightforward. So how evaluate expression is done for Java? First, I, of course, came over to the next room and asked IntelliJ guys, like, how we do that? And they told me that they have an interpreter. So basically, when you ask IntelliJ to evaluate a Java expression, it analyzes it the way it does for IDE services, builds an AST, binds the names, and then interprets the expressions. Like there is dedicated code, not very small, not very big, but still done from scratch, that implements Java semantics, delegating the method calls and memory reads to the debugger. OK, well, do I really need to re-implement the whole semantics of Kotlin again as an interpreter? Don't want to do that, really. Well, it's a lot of work first, then it may be, there may be discrepancies in how it works. So I would really like to reuse my compiler. Then, OK, maybe IntelliJ, which is actually calling the compiler as an external process, isn't that intimate with the compiler. Maybe some others do it differently. So I went to other IDEs and asked how they do that. Eclipse was my big hope, actually, because they are very tightly integrated with the compiler. The compiler is basically the core of the IDE. So I hope that they may have actually reused the logic in the compiler. For evaluate expression, unfortunately, Eclipse has an interpreter. A rather interestingly implemented, but still an interpreter that has nothing to do with the compiler logic. It doesn't use the bytecode generated, so on and so forth. I turned to other IDEs that own their own compilers. Well, no luck there, no interpreters even. So it seems that nowadays, you either have an interpreter that duplicates the logic, the semantics of your language, duplicates your compiler, or not have evaluate expression at all, which is kind of unfortunate. So I see some room for improvement there. And so the obvious idea is, OK, I have my compiler, I have the expression, I compile the expression, and somehow run it on the other side. So a naive thing would be to say, OK, I have my a plus b, I can get a class file out of it somehow. Of course, you don't compile a plus b directly to a class file. You have to wrap it into something, but still. Then you somehow load it into the debugging process. You run it there. You get the results. We're fine. Well, unfortunately, this is not very straightforward to implement. And I haven't entirely given up on this simple approach, but I don't know how to make it work. Because in this particular case, we are in a very bad situation. So what I want is to evaluate x plus 2, and my x is private. So if I just create another class that wants x, it will fail with the legal access, and that's it. So what we are actually doing now is some kind of a mixed approach where we have an interpreter, but not an interpreter for Kotlin, rather an interpreter for JVM bytecode. So instead of just doing the semantics of Kotlin, I decided I'd better do semantics of the bytecode because that first doesn't change that often, and second, all the tricky logic and optimizations and everything that are in my compiler can be reused. And also, you guys may want to use that interpreter as well. So the idea there is that if you have an expression like foo.x plus 2, you compile it, and then you interpret many of the instructions just in the process of the debugger and delegate the actual reads and method calls to the JDI. This is not that hard. The implementation of this, I actually had to implement it more or less from scratch. I reused the ASM's abstract interpreter, which is not actually designed for actual interpretation. It's for abstract interpretation. So it was very little to reuse. I was surprised that I couldn't find any Java bytecode interpreter implemented in Java. The pure Java JVMs were my big hope, but they don't seem to interpret bytecode at all. They just did compile. So I had to do that. It wasn't that much work. It's like 1,300 lines of code in Kotlin. Not very bad. So, and I'm going to tell you how it all turns out and what subtleties are there. Questions? Yeah. OK. Yeah.
How can you compile that program given that there's still a private access?
OK, yeah, that's a good question. I will give you an answer a little later. Yeah.
You try rewriting the bytecode to all the get field and invoke static to replace it with invoke dynamic, and then you find it method.
OK, yeah, the question is, do we try to work around the privates problem? Do we try to replace all the bad accesses with invoke dynamic? The answer is there is Java 6 out there, and I'm not daring doing that. Well, actually, Kotlin still targets Java 6 today. And yeah, so I'm all eager to use all the fancy stuff we have already for so long time, but the reality is a little rougher. OK, so how do you compile an expression? So first of all, when you have an expression, it's not like a closed term. It's supposed to have, so it's very likely to have free variables there, because what the user wants is to derive some data from the current state of the program. It's not like just a constant expression he wants to evaluate. So having those free variables there you probably want to turn your expression into something compilable, which is likely to be a function that just captures the free variables as parameters. And now it's some work to analyze the expression. Well, first of all, when you're stopped somewhere at the breakpoint, you have your expression, which is not part of your program, so you have to teach your compiler to analyze an expression in the current context, which is kind of natural for an IDE anyway, so you have that. And also you have to compute your, say, closure or something of this expression. The compiler obviously does that, but actually on a lot lower level, because you don't operate like on pure source code when you compute closures. But still, in an IDE, you have enough functionality already there to find this function. It's called extract method refactoring. So what you do, you simply say, OK, here's my expression. Extract it as a function. This is something available only for the IDE. Otherwise, you would have to do something more involved. But still, you can do that. We do this. Any decent IDE has extract methods, so you can actually reuse this approach for your language as well. Now, addressing Mauritius' question, what if X is private? Well, fortunately, there is this very nice approach we borrowed from Eclipse, that the compiler will emit the code unless it totally cannot. So to compile something that accesses a private in the body of the function, we will ignore the error and just emit the code. It wouldn't run, but we interpret it, so yeah. So the debugger is powerful enough to actually access privates on the debuggy side. So this is one problem you have with extract functions, so you have to tolerate access restrictions. And also, there is another class of problems. What if my foo was of an anonymous type, or somehow else not a notable type? That's a problem. You have to teach your extract function to tolerate that just for your debugger. And you have to teach the compiler to tolerate a non-denotable type. So this is something we are doing just below the level of the text input. We just build an ASC for the text, for the function instead of just compiling the text. But more or less, it's a very simple trick. It's not very hard to modify your compiler to do this. So far, we're in pretty good shape. We just take our extract method, our compiler, the interpreter, and we have evaluate expression. All good. Any questions at this point? Go ahead. No, these are for, so we are talking interactive debugging here. So it's for inspecting your expressions just in the code, doing conditional breakpoints, watches, whatever. Okay, so watches. Yeah. I guess one question I have is, can you inject this stuff into the bytecode that's generated by your code? You say, OK, well, I want to know what x plus 2 is here. I'll just inject the code into that method. And that statement runs the really. OK. Yeah, so the question is, why can I not simply inject the expressions I want into the code? So the answer number one is most of the time you come up with that expression after you run the program. So you're inventing your watches on the go. You can probably do bytecode reloading. Yes, and some people actually try that. Let me see. So this may be a viable approach. I'm not entirely sure. Oh, yeah. So I see one problem there. If I'm in the middle of a method, if I do a reload just standing on a breakpoint, the JVM is likely to hang for a reason unknown to me. And then, so I have to find a point to inject the expression into without breaking the surroundings there. And say, if I throw an exception from there, it will handle my exception in that method, which is no good. And I'll tell you a little bit more on the threading problems there a little later. There are some subtleties there, too. Yeah? Good point, too. OK, so yeah, it would be very nice to just make the JVM on the other side somehow work for me, but there is no really nice way of doing that. And I'll come to some more details on that a little later. More questions? OK, let's go. So another challenge. So all that was good. And this more or less covers what other IDEs have for Java today. But what they don't have for Java is lambdas, anonymous classes, local classes. So if in your expression you use a lambda, so it's not supported in any evaluate expression, neither IntelliJ nor Eclipse nor NetBeans gives you that, which is unfortunate for Java 8, I think. And the biggest problems there are that here you have to basically come up with a new class and make the other side know that there is this class. And of course, that class may access privates of somebody else, and that is a problem too. So we have to somehow figure out two problems. What do we do about loading a new class into the debugging process? And what do we do when it wants privates? OK, so yeah. First of all, how do we load into the other side? When I'm stopped at a breakpoint, I have the current execution context. I see the threads. I see the class loaders. So a naive approach that many people actually suggest is, OK, you see that there is a class loader on the other side. Just write to the file system, add the class file there where it expects it, and we'll load it, and you're fine. So thing number one, it may be a remote debugging. So I do not necessarily have access to the file system. Problem number two, it may not be a URL class loader at all. Maybe a custom class loader, maybe whatever, actually. So this is not going to work. So what we are currently doing, this is not the only possible approach, but this is something we're doing at the moment, and it works. So fortunately, my debugger can call anything. Privates, protected methods, whatever. So I can take any class loader and just make it define a class from bytes. So I have my class compiled on the side of the debugger, just a sequence of bytes. I wrap them as a JDI values, which is actually horribly slow. So what we're going to do is somehow compress that, transfer it to the other side, and just call define class on whatever class loader I have my hands on to make it load those bytes. I have to be very careful about naming. So the current policy is that we're putting the classes in the package called 0, which is unlikely to be accessed by anybody else. You have to be careful about that. You have to be sure that your class gets more or less properly processed. So fortunately, the implementation of the class loaders that I have little idea about works so that if you call the define class, then you get a somehow unprepared class. It's not linked. It's not prepared in any other way. But then when somebody calls class for name on that, it magically loads with no problem. So we can teach a class loader to just know that those bytes are loaded as a class. That's great. So this hack works. And you can load your class on the other side. It will remain there, unfortunately, so you cannot easily unload it. So we will experiment a little bit with maybe creating our custom class loading class loader instance just for it to get garbage collected when we're done evaluating. But anyways, something like this works. And now for privates. So a natural question would be, OK, an inner class can access privates of the outer class. Can you use that mechanism? The answer is not quite, because this is happening on the language level, not on the JVM level. So how the access of from the nested class to the outer class works is that the compiler, whatever compiler, Java C or Kotlin C, is adding those static access methods to the class that owns a private that are synthetic. They're not visible to others, from the language, but they expose the actual privates to the client concerned. And we cannot insert a method into an existing class because hot swap doesn't support that. OK, so what do we do? Any ideas?
Unsafe.define anonymous class.
define anonymous class. How is it going to help us?
It loads a nameless garbage collectible class that has the exact access rights specified in those classes.
OK, this is a wonderful thing. Yeah, thank you very much. So OK, you'll tell me about that a little more. So it's great that you have those wonderful ideas. I'll tell you my bad solution then. I hope that the simpler ones work, and it will simplify my work a lot. So what we do at the moment is a little bit more, yeah, OK. I'll still tell you it's a funny idea anyways. So since the body of the method may be bad, it may try to access the privates somewhere. But the debugger actually has the right to access those privates. We decided that we simply interpret the contents of the method on the debugger side. So what we want is the other side, the debuggy process, to call the method. Then we stop there at a breakpoint, evaluate what we need, and make it return what we want. So to do that, we could use JDI to make it return something, but couldn't use it to make it throw if it has to throw. So what we do is this funny code here. We replace the bodies of all methods with this stub code, which basically simply defines two locals, one for the result, another for exception. And so if the exception is null, which it is, then it returns the result, otherwise it throws. So what we do next, we stop at the breakpoint here, evaluate what we want, reassign the locals, and resume the process. So if we assign something to the exception, it will throw. Otherwise, it will return what we want. I hope that the other solutions work better, because this has some drawbacks to it. First of all, we have to transform the bytecode, remember on the other side that there is some body to this method, so on and so forth. And second thing is that we have to play really badly with the breakpoints, because I was stopped first at a breakpoint, then I stopped at another one and resumed there, and so I'm not stopped at the first one anymore. And that's a bad thing, because I didn't want to resume the user's process at all. I wanted just to evaluate my expression. That was it. So to work around that, we have to actually spawn a new thread that would basically run in a loop with a breakpoint in it, and give us a resume thread whenever we want. So we can evaluate on that thread. And to make it ever finish, we actually have the second version there with a flag that we can set and make it stop. Any questions at this point? What's that? How do I make the memory model work? It's a good question. Well, actually, yeah, this is something that debuggers are not very careful about, ever. I'm not really sure. And if anybody is knowledgeable about the internals of JDI, I would be curious to know that. But my impression is that when you stop at a breakpoint, it somehow affects the actual state of the threads. And so it doesn't necessarily establish any happens before relations, but caches are very likely to get flushed. So many things go smoother there, although there is no such guarantee, of course. Yeah, but so currently we do as much as any debugger does, which is nothing. Yeah, because basically what you do when you evaluate something, you evaluate on the first thread you found. Because it's suspended, you do something there. So it may actually deadlock, because other threads are suspended, and if they are supposed to respond, it may just block forever. And there are some workarounds for that. Yeah, more questions? I'm actually almost done, so you can ask even very involved questions, since I'm not going to dig very much into the hacks anyways. Yeah?
So I've been thinking as you've been talking about it, have you considered how you're going to cope with invoke dynamic?
Yeah, wonderful question. So our current implementation of the interpreter does not support invoke dynamic because we target 6. So I did consider that a little. It's going to be hard, but likely possible.
I was wondering whether you could effectively evaluate bootstraps on the JVM you're debugging, keep handles on the generated call sites, and use method calls to go and trigger that behavior.
Yeah.
I think that's the only way you can guarantee that you'll get something close to the right answer.
Yeah, you're right. So when we're talking about things that exist on the other side, we definitely should evaluate on the other side and get the values to actually remember and link at the call site. So the unpleasant part is that we probably will have to implement at least partly all the caching and linking and everything in the interpreter, because there is no way around it. So another question is, what if the classes, what if some of the things we are coming up with do not exist on the other side? Like, what if we generated a static method for a Lambda and want to link to that? So the current answer is we do not generate static methods there. We just always create inner classes. Yeah. So resume. If you have a static language and you don't have evaluate expression yet, just grab this and use it at least without lambdas. It will work for you very cleanly. And more or less for free, if you have an extract method, you get your debugger to do what you want. If you want lambdas, well, probably with the suggestion from John or Lauri, we will get even better. If you have a dynamic language, so the only one IDE for a dynamic language I looked at regarding evaluate expression was Groovy in IntelliJ. And they're doing something very interesting. I didn't actually go very deep into that, but they're trying to translate a Groovy expression into a Java expression and piggyback on the interpreter they have there, which kind of suggests to me that it's not straightforward to evaluate a Groovy expression in the debugger. I mean, you just don't get the Groovy interpreter and run the expression right away. So hopefully in your dynamic languages, you have more freedom, but if it's not enough, you can take this as well. More questions? Okay, thank you very much. My short talk is over.